Assalamualaikum warahmatullahi wabarakatuh. My name is Sidatul Muntaha Khairul Azman, matching number 078334. Our group represent about case study for student hostel allocation. This case study explores the challenges of allocating students in hostel rooms in universities, where limited spaces must be matched with student needs and room availability. This includes preference like room type allocations, requirements such as medical conditions and special needs, and constraints like roommate compatibility and accessibility. Traditional manual methods are often inefficient and unfair, leading to dissatisfaction and complaints. To address this, algorithmic approaches such as branch and bound, backtracking, greedy, and network flow offer smart, scalable solutions that improve speed, fairness, and transparency. This scenario offers a practical way to apply algorithm design principles to a real-world problem faced by a higher education institution.
Assalamualaikum. My name is Nur Shariza binti Sakari. Metric number is 078564. So today I will present the summary of our analysis finding for the student hostel allocation project. Algorithm choosing. After comparing four algorithms, we choose the network flow algorithm as the most suitable for our case. This algorithm gives optimal and fair result, and it works well by modeling the problem as a bipartite graph where the students are matched to rooms based on their preference and room capacities. In our case, each student got a suitable room with no conflict, which show a successful base case scenario. And why others algorithm were not chosen? We also tested other algorithm. We have four algorithm, uh, and we choose the network flow algorithm. And the another three is first greedy. Greedy is very fast, but it sometimes make decision too quickly and miss a better match. Second is backtracking. Backtracking is a very accurate and follow all rules, but it's too slow as data size increase. And third is brush and bound. Brush and bound is faster than backtracking because it skips bad option early. But even so, it's not ideal for large problems. For our small case, this algorithm work, but network flow give the clearest and most structured solution. And next is trade-off analysis. We choose network flow because it gives the best balance between speed and accuracy. It ensures maximum matching while respecting fairness and constraint. So in our case, it handles the student preference perfectly with efficient result. For input data and focus, in our analysis, we use input data for case study that is 4 students and 4 rooms. And lastly is we focus on the base case scenario where all students had clear preference, where there were no conflict and each room was assigned to one student successful. So for the summary is we found that the network flow algorithm is the most effective for solving hostel room allocation problems, especially when the input is clear and conflict free, like in our case. Thank you.
I am Alia Sofia Bintayub, metric number 078168, will present about the rationale in choosing our algorithm. To decide which algorithm best fits the hostel allocation problem, our group used 5 main criteria, by which scalability, as in can it handle a large number of students and rooms. Next, fairness, as in does it ensure students' preferences and special needs are respected. Optimality, in terms of if the algorithm aims for the best possible allocation outcome, practical feasibility, as in is it realistic to implement it in a university environment. Next is execution time, by which can it produce result efficiently, especially under tight timelines. By using this criteria, 4 algorithms are selected, which are network flow algorithm, branch and bound algorithm, backtracking, and also greedy algorithm. In our case study, we consider network flow algorithm as the best option for hostel allocations, as it models the problem as a graph for an optimal matching of student rooms. Next, the graph also makes it scalable for thousands of students, and it balances efficiency and fairness. Also, the different flows in the graph respects capacity constraints and also special requirements. We also consider other algorithms, which is branch and bound. Branch and bound is better than backtracking, as it prunes the bad options early, thus finding a fairer allocation. But it is still computationally expensive for large datasets, so we do not choose it, as it have good trade-off, but it is not the very best for large cases. Next, we have backtracking, by which backtracking works the same as branch and bound, but the difference is that we do not prune the bad options early. We consider all the combinations, which makes it guarantees constraint satisfaction. The problem with backtracking is that it is very slow with large student numbers, so it is not very practical for universities with thousands of education. So that's why we do not choose it, as it is accurate but not very scalable. And the last one is greedy algorithm. Greedy algorithm is fast and very easy to implement, but it cannot backtrack, which ignores fairness and constraints, often results in imbalance. For example, the early students can get better rooms, but the other students that are late cannot. So we do not choose it, as it is too simple for real-world hostel allocations. So overall, that is why we selected network flow algorithm, because it strikes the right balance across all the 5 criteria, by which it is scalable, it is fair, it is optimal, it is practical, and it is efficient. It makes it stands out as the most appropriate algorithm for real-world university setting, where thousands of students and multiple constraints are involved.
For our analysis decision, we standardize the input size to small scale, 4 students and 4 rooms. This allows us to apply all algorithms fairly and compare their performance under the same conditions. The problem we are addressing is how to assign hostel room fairly and efficiently, especially dealing with large data. The allocation must consider students' preference, constraints, and availability. We made a few assumptions to simplify the model. Each student is assigned to exactly 1 room, each room is assigned to 1 student, and all algorithms are tested using the same problem size for fair comparison. Our case focus is based on the best case scenario, where students' top preference don't overlap. This reflects a realistic but ideal situation where constraints are minimal and the algorithms can perform at their best. Finally, looking at the trade-offs, greedy and network flow are fast, but only network flow guarantees optimal results with good scalability, while the backtracking and branch and bound guarantees optimality but struggle with time and scalability.
Assalamualaikum warahmatullahi wabarakatuh. My name is Noadila Sofia Batirusmadi and my metric number is 079315. And I will be talking about process and collaboration management for challenges and solutions. So, during our project, we encountered a few challenges, but we addressed them with effective strategies. First, one of the main challenges was maintaining clear and timely communication among team members. To overcome this, we use WhatsApp for quick updates and held weekly face-to-face meetings. This helps us stay informed, discuss progress, and resolve any issue promptly. Second, staying focused and meeting deadline was another challenge. To manage this, we set clear goals at different stages of the project.
This goal helped to keep the team aligned and ensure that the tasks were complete on time. Lastly, it was important to ensure that tasks were assigned clearly and fairly so that everyone understood their responsibilities. We addressed this by distributing tasks evenly based on different parts of the project. This made sure that workload was balanced and everyone contributed effectively. So by tackling these challenges thoughtfully, we are able to work efficiently and maintain strong teamwork throughout the project. Thank you.
My name is Fatana Nabila binti Fazil. My metric number 079294, and I will continue our presentation with the overall recommendation and the conclusion. So among the algorithm we look at, which is branch and bound algorithm, backtracking algorithm, greedy algorithm, and network flow algorithm, only one that clearly stands out, which is the network flow algorithm. The reason why, because it's handle complex, large-scale assignment while respecting real-world constraints like group capacity and student preference. It also visualizes the whole allocation problem as a flow, from student to rooms, ensuring each allocation is optimal, fair, and rule-based. So we recommend that the university should adopt a network flow-based system for hostel allocation. So this approach enables fully automated, transparent, and scalabilization. It reduces administrative pressure and eliminated bias, and most importantly, it can boost the students' satisfaction by matching them with the most suitable option available. In short, this is not just a theoretical fix. It's a realistic data-driven strategy that directly responds to the evolving challenges faced by the universities today. As the student numbers grows, as the expectation around fairness and personalization and efficiency rise, institutions can no longer rely on the outdated system that are slow, inconsistent, and difficult to manage at scale. So, a network flow-based allocation system is grounded in real data. It uses actual student preference, room capacity, and constraints to make a smart solution. So that means every allocation is based on the logic and fairness. I think that's all from our group. Thank you for listening to our presentation.